Alright, you guys, so we have seen some nuances about our inverse functions, and it really relates to everything, right? Our function has to be one-to-one, because if it's not, that doesn't mean the inverse doesn't exist, as we've seen. It's harder to find, or there's some nuances, there's things that we have to be aware of and we have to be careful of when we claim that something is in fact an inverse. So let's go ahead and do that investigation officially here. I'm going to start off with a function. It's a quadratic function, and if we're using what we've learned to graph it, right? This is basically our x squared function that's been shifted to the right 1 and up 3, right? So here's basically what this function looks like. So clearly this is not one-to-one, right? It fails the horizontal line test miserably, right? But we are going to be asked, right, to find the inverse of this function, right? And it does actually exist because we are familiar with the fact that if I want to reverse a square, I take a square root. So our gut is telling us that an inverse exists, all right? But our theory right now is a little hairy, if you would, because it's not a one-to-one function. So here's what's going to happen. Let's go through our little thing here. This is also going to explain another aspect of the square root property that's very, very important to get everything right. So if we follow what we've been learning, right, I've got to take my function and I've got to reverse the roles, right, of the x and the y. And then what I have to do is solve it. So I'll subtract 3 from both sides. I get x minus 3 equals 1, y minus 1 squared. Now when I take a square root here, right, what we have learned is I have introduced a plus minus to the problem. There's a plus and there's a minus square root to this. So we end up with, let me rewrite this as y minus 1 equals plus or minus the square root of x minus 3. And if we now add 1 to both sides, right, we get that y is plus or minus the square root of x minus 3 plus 1. So what this is basically telling us is that the inverse does exist, but there's two of them, right? One of our inverses is the positive x minus 3, square root of x minus 3 plus 1, and the other one is the negative x minus 3 plus 1. All right? And so what we have to do to figure out which one do I want, we essentially have to restrict the domain here, because if I, starting at 1, if I looked at values to this guy right here, what I end up with, right, is that part there. And so if we, I'll go to technology in a moment, but right, there's our line y equals x. So that means that the graph of the inverse, right, and both of these do this, right, this is a square root function that's been shifted to the right 3 and up 1. So 1, 2, 3, and up 1, right? But the positive square root, right, will do this. And the negative square root is going to be down here. All right? And you'll notice that what I have in red, this part of that parabola matches the positive square root of x minus 3, as opposed to if we were to do this part, right? If we were to go ahead and let x be less than 1, we would have that part, and it would actually be symmetric with that part, which is the negative. So basically these guys are inverses, right? The negative square root are inverses, right? If so, this would be negative x minus 3 plus 1 if x was less than 1, and then in red we have the square root of x minus 3 plus 1 if x was greater than 1. And so that is how we work around. If we have a one-to-one, if we have a function that is not one-to-one, what we do is we restrict the domain so that the one-to-one situation occurs, and then we can match the function that I want. And a classic one is x squared, because when we take a square root, we've introduced a plus or minus, and some of you keep dropping it, and now you see that it's always been important, you know, in our work, and now it becomes central. So I can figure out, well, which there is an inverse, but which one do I need for the restricted domain that I have? So my picture's a little crazy. So let me go ahead and kind of go to this. So here again, right, in red, I think I have another function on. So here in red, I have the graph of x minus 1 squared plus 3. So I got the full graph. We know that it's not 1 to 1, all right? But what I have learned is I finally figured out how to do it. I can restrict the domain, all right? So there's the same graph, but we're now restricted to x is greater than or equal to 1. So now, right, with that restriction, we got rid of the other half of the parabola, so now it's 1 to 1. And which function is that going to be an inverse of? Well, from our work, we know that's the positive square root of x plus 3. And let me change colors here so we can kind of see that, right? And so there's the line y equals x, and we do see that those graphs do in fact, let me scoot out a little bit more, right? They are in fact mimicking each other, right, or symmetric with each other through the line y equals x. So that means we've nailed it, right? We've got it. So we have that. So again, that's if we restrict things greater than 1. If we do the other one, right, so if I do that restriction, now you can see that that positive square root isn't quite the inverse of that part of that graph. So that's where the negative comes into play. So let me turn that one on and turn that one off. And what we basically see, right, is what we have there. So now that part lies in line with that. So that is how we get around that situation. When you have a function that's not 1 to 1, what we do is we break it up in pieces and we find, right, we go ahead and go through our work, and then we kind of have to piece together, well, which one of these matches with one of these, so all my math works out. And it gets very complicated. Right now, x squared is probably the easiest one, but you know, later on, some of you are going to be moving into not calculus, but trigonometry. And in trigonometry, one of the classic graphs that we deal with is what we call a sine graph, right? And so there's 0, here's pi over 2, and negative pi over 2. Hopefully I'm not scaring too many of you. There's pi and negative pi respectively. So one of the things about the sine is it's not 1 to 1. Right? But what we do is we actually restrict the domain. We restrict it from here to here. And if you took all the rest away, right, on that little domain restriction, the function is in fact 1 to 1. And so then we should and we can find the inverse function. For you guys, if you have your TI calculator, I think there's a key that says sine on it, and then its secondary function is sine inverse. All right? And so that sine inverse is for that restricted domain that we have there. And I know I'm kind of jumping ahead, but I just want you guys to see that even though we have functions that are not 1 to 1, there are ways to work around finding that inverse. We just have to restrict our domain somehow to get the job done. Otherwise, what we're very hopeful for, like I did here, we're just hopeful that the function already starts 1 to 1, and the inverse that I find happens to be the inverse all the time. There's no nuances or no restricted domains. All right, so that wraps up our inverse conversation. All right, so if you have questions, you better ask them. Jump on Canvas and ask your questions there. Send me an email or request an office hour time where you and I can sit down and talk and get through some of these nuances. All right, you guys? So good luck on your quiz, and I'll see you guys in the next section.